kinetic energy of simple harmonic oscillator. So kinetic energy, from here that kinetic energy is coming due to the motion or due to the velocity, right? So that kinetic energy, let us denote that notation, that is T. So it will be basically half m omega, sorry, half m v square, right? And you know what is v. So if you substitute that expression for v, so it will be half m. V was omega root over a square minus x square. So we can write omega square. And let us take that amplitude factor is capital A, because it will be confusing with acceleration notation. So let us take that amplitude as a capital A. So it will be capital A square minus x square. So this is the kinetic energy of your simple harmonic oscillator. Now what will be the potential energy? How will calculate the potential energy? So let us take potential energy. Actually, we cannot calculate potential energy. We always used to calculate change in potential energy, right? We always used to calculate change in potential energy. Now let us draw a simple picture. Suppose you have simple harmonic oscillator. Initially it was in equilibrium position at x equals to 0. Now we have displaced this particle by amount of x. So work done will be how much? Work done will be how much? So work done will be minus f dx, and you have displaced that particle from dx equals to 0 to some arbitrary x. And change work done is nothing but change in potential energy. Did you get what I am saying? So initially you have simple harmonic oscillator, it is at equilibrium position. Now you displace this particle or simple oscillator by amount of x. So to displace this oscillator by amount x, you have to do some work done. So that work done is f dx with initial value x equals to 0 to x. So this is your work done, and work done is nothing but change in potential energy, right? So dv minus dv0. Sorry, change in potential energy. Let us take that notation dv. Okay. So initially when it is at equilibrium, that potential energy I am taking 0, but it is not necessary that particle when it is at equilibrium, that potential energy will always be 0. So for the sake of convenience, I am taking that particle when it is at equilibrium position, its potential energy is 0. Now if you are stretching by amount x, let us take that potential energy is v. Okay. Now you know f is what? Basically minus kx. If you substitute it, so kx dx. So if you integrate it, you will get v equals to kx square by 2. And you know k is what? Because you already have defined omega square equals to k by m. So it means k equals to m omega square. So if you substitute it, you will get basically m omega square x square by 2. Is this part clear? This is part clear to all?
Yes, sir.
Okay, so you got kinetic energy as well as potential energy. Now add this and calculate how much will be the total energy. So total energy E equals to sum over kinetic energy plus potential energy, right? So you have kinetic energy, that is how half m omega square, then a square minus x square, and you have potential energy of your oscillator, that is half m omega square x square. So if we add it, clearly it can be noticeable that this term will be cancelled. So if you see, this will be minus m omega square x square by 2, and it will be cancelled with this term. So you basically will get a half m omega square a square. So total energy of your oscillator is always constant, and this is actually the ideal case. So you can see from here that when the particle is performing simple harmonic motion, is total energy will always be constant. Total energy will always be constant. What does it mean? Wherever that oscillator is, it is at mean position, somewhere else, at extreme position, everywhere you will get that much of energy. But this is the ideal case. If you place this oscillator in some medium or obviously there will be drag or some damping or resistance will be there. So that time energy will not be constant, it will be decreasing with time. But since we are dealing with simple harmonic oscillator, so this is actually the ideal case. When I'll go to the damp oscillator, that time we'll discuss that energy will no longer be constant. So what I'm saying that energy of your oscillator for simple harmonic case will always be constant no matter wherever your system is. It is at equilibrium, somewhere else, or extreme position. Everywhere you will get how much energy? This much of energy. Now, if you plot that kinetic energy and potential energy curve, how it will look like? So let us take a look. Let us take this is the equilibrium position, and this is the extreme position, A and minus A. Or let us take capital A. Okay. So if you draw that kinetic energy, so you know that kinetic energy at this position will be at equilibrium position will be the maximum. Okay. And at extreme position it will be minimum. You can check from here. If you put x equals to 0, your kinetic energy will be maximum because this is the kinetic energy term. If you put x equals to 0, x equals to 0 means equilibrium position. At this place, you will have maximum kinetic energy. But when you will put x equals to a, x equals to a means that oscillator is at extreme position. That time you will have kinetic energy equals to 0, and that is basically minimum kinetic energy. So kinetic energy plot will be looking like this. And what about potential energy? So potential energy will be minimum at equilibrium position because this is half m omega square x square. So when x is 0, potential energy is 0. At extreme position means x equals to plus minus a. At this position, you will have maximum potential energy. So potential energy curve will be looking like okay. Is this part clear to all? Is this part clear to all?
Yes, sir.
Yes, sir.
Now, can you please tell me? So you got that equation, you got that information that kinetic energy, sorry, velocity is maximum at mean position and acceleration is maximum at extreme position. Now, can you please tell me at what position the product of what position the product of kinetic energy means capital T, and potential energy, that will be maximum, at what position? So the question is at what position the product of kinetic energy and potential energy will be maximum. So let me check. So let us write that product of kinetic energy and potential energy. So it will be basically half m omega square a square minus x square. This is your kinetic energy, and potential energy is half m omega square x square. This is equals to, this is all about your product of kinetic energy and potential energy. Now to check maximum, how will check maximum? Because you can clearly see this product of kinetic energy and potential energy is a function of displacement, right? So to check where it will be the maximum, what you have to do, you have to differentiate this with respect to x, and you have to put this equals to 0. So if you put it 0, now if you differentiate this function, you will basically get m omega square whole square by 2. This is constant factor. Now if you bring this x square inside this bracket and if you differentiate it with respect to x, basically you will get 2x a square minus 4x cube, that will be 0. Since this factor cannot be 0 because omega is a frequency, m is the mass, that are non-zero quantity, so this term should be 0. So what I can write 2x. Also, I can take 2x common, right? If you take 2x common from this bracket, you will get basically 2x a square minus 2x square equals to 0. So you can get two terms, x equals to 0 either, or x equals to plus minus a by root 2. Is this part clear to all? So I am looking at what position from that mean position, at what point the product of kinetic energy and potential energy, that will be maximum. So for that you have to just differentiate with respect to x, and that you have to set equals to 0 because this is the well-known equation to check maximum or minimum, right? Now if you solve it, a very simple equation is there. You will get 2 points, x equals to 0 or x equals to plus minus a by root 2. Now can you please tell me anyone at which place the product will be maximum? So you got two terms, right? Or 2 points. Not only 2 points, you can say 3 points. Plus minus a by root 2 also is there. Anyone? So you got 2 points. Now if you differentiate with make double differentiation, del square t v by del x square, and if you put x equals to 0, you will get some positive number. And you know, for if that double differentiation is giving positive number, that is basically representing minimum, right? That is basically representing minimum, right? Is this part clear to all what I'm saying?
Yes, sir.
Yes, sir.
Yes. If you put del square TV by del x square at x equals to plus minus a by root 2, you can check from this equation. I'm giving you hints. You can do it very simply. Calculation is there. You will get negative value. It means at this point, the function will have maximum value. So what is the answer now? So TV will be maximum at x equals to plus minus a by root 2. Is this part clear to all what I'm saying?
Yes, sir.
So you already have
Yes, sir.
time खत्म हो गया आप लोगों का 6:40 तक था ना क्लास? So you have mathematical physics class, right?
Yes, sir.
Yes, sir.
Okay. Then we should stop here. Tomorrow we'll discuss. So आप लोगों को समझ में आ रहा है क्लास में?
Yes, sir.
Yes, sir.
Sir, एक डाउट पूछ सकते?
जी पूछो.
Please send the study material of soft copy in Google Classroom.
Yes, yes. Satish sir will provide you. Okay.
Sir,
Are you enjoying class?
Yes, sir.
हाँ किसी का कोई डाउट था बोलो. क्या डाउट है?
हाँ सर, वो जो हमने v को मतलब वेलोसिटी इक्वल टू 0 बोला था, अगर एक्सट्रीम पोजीशन है
हाँ हाँ.
तो हमारी एक्सेलरेशन तो रेट ऑफ चेंज ऑफ वेलोसिटी होता है ना, तो वो कैसे हुआ मैक्सिमम?
देखो एक्चुअली होता है इधर, वही तो बात है ना. एक्सेलरेशन का डायरेक्शन देखो किधर है. एक्सेलरेशन का डायरेक्शन, वेलोसिटी इधर है आपका. वेलोसिटी किधर है? जब पार्टिकल इधर मूव कर रहा है वेलोसिटी इधर है, राइट? और एक्सेलरेशन किधर है? इधर है. एक्चुअली जब पार्टिकल इधर जाने की कोशिश कर रहा है, एक्सेलरेशन मैक्सिमम हो रहा है, उसीलिए पार्टिकल यहाँ पे स्टॉप हो रहा है. अगर एक्सेलरेशन मैक्सिमम ना होता तो पार्टिकल और भी चले जाते. You can clearly see acceleration actually acting in which direction is this direction. जिधर पार्टिकल का मोशन है ऑपोजिट में आपका एक्सिलरेशन है ना? तो इस पॉइंट में इसीलिए रुक रहा है क्योंकि इस पॉइंट में आपका मैक्सिमम एक्सिलरेशन है, इसीलिए पार्टिकल रुक रहा है यहाँ पे, बिकॉज बोथ आर इन ऑपोजिट डायरेक्शन. Okay.
Sir. Got it, sir. Oh, got it. Sir. Thank you.
Any more question? So I think if people got why that simple harmonic oscillator is so important in physics. Okay. So if you have no question, I can stop here.
Thank you, sir.
Welcome.
Thank you, sir.